Hello friends and dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is part 2 video from the chapter of Exponents of Real Numbers, where I will discuss about some concepts and formulas about the rational exponents of real numbers and the laws of rational exponents. So this video is part of the playlist CBSE Maths for class 9 following the textbook of author R.D. Sharma. In this playlist, I only discuss about the key concepts and formulas related to problem solving. For extensive theoretical concept, you have to please consult your preferred textbook. Okay, I hope you have seen the part 1 video where I discussed about the principal nth root of a real number, of a positive real number, and the principal nth root of the negative real number. If you have not watched that video, I strongly suggest that you please watch that video. If you find this video beneficial, then please like it, share it with your friends, and if you want to further support me, then please subscribe to my channel, and in that case do not forget to press the bell icon so that you will be notified by my future videos. So let's start part 2 video where I will discuss about rational exponents of real numbers and their laws. Okay, so I am not really prepared. As you can see, it's a blank canvas. I do not have any notes prepared. I will discuss from scratch. Okay, now before discussing the rational exponents of real numbers, that is exponents of real, that is exponents where the base is a real number and the power index is a rational number, let me first clarify few things, very crucial things regarding exponents. Okay, now whenever you have exponents of the form, let's say x to the power some negative power minus n. Now this n, sorry, please do not consider this n to be an integer. It could also be, let's say, minus n, where n is some positive integer, or of the form x to the power minus p by q, where p by q is a rational number, is a positive rational number, and x is a x is a real number. Now whenever the power is negative, whether it is or whether the power is a negative integer or negative rational number, the base cannot be 0. In this case the base is the base x is not equals to 0, because the moment x is become 0, these two expressions will be not defined, because x to the power minus n is nothing but 1 by x to the power n, and and x to the power similarly minus p by q is nothing but 1 by x to the power p by q. So if in these two expressions where the power is negative, negative rational number or negative integer, x, the base cannot be 0. Why? Note that before y with x cannot be 0, note that 0 to the power y, this exponent, this exponential form will only be is defined for only y greater than 0. If the base is 0, then the power can be any positive number and it will be valid, and this is if y is any positive number, if y is any positive real number, then 0 to the power y is always equal to 0. And this was one thing, important thing, is defined for only y greater than 0, and if y is greater than 0, then 0 to the power y is always equal to 0. Another thing is that any real number to the power 0, this is equal to 1 only when x is not equals to 0. For any base, for any non-zero base, if the power is 0, then that exponential term will be equals to 1. It is assumed to be 1, but x has to be non-zero. X can be negative or x can be positive, but it cannot be 0. Now in this case, I was discussing that in the expression exponential form, x to the power minus n or x to the power minus p by q, x cannot be 0. Why if x becomes 0, x to the power minus n is 1 by x to the power n, and 1 if x is 0, 0 to the power n, since n is a positive integer, 1 by 0 to the power n will be 1 by 0, and this is not defined. Division by 0 is not defined in mathematics. Similarly, here also, if x becomes 0, then 1 by 0 to the power p by q, and since p by q is a positive rational number or positive real number, then 0, this will be equal to 0, also not defined. So whenever you have an exponential term where the power is some negative number, like negative integer or negative rational number, then the base cannot be 0. Base has to be non-zero. And also 0 to the power anything is always equals to 0, provided that power is a positive number. And the third is, if the power is 0, then the base has to be a non-zero real number. Any non-zero real number raised to the power 0 is assumed to be 1. So these three things you have to always keep in mind. Okay, so now we will discuss what do we mean when we raise a real number. Let's say if x is a real number, x, if we raise this to a power which is a rational number. Now in this rational number, the rational number should be in standard form, that is q is greater than 0. Q is greater than 0. What exactly it means, x to the power where the power is a rational number. This is, how do we interpret this? Where where q is greater than 0. So this is nothing but this you can rewrite it as x x. Now the rational number p by q can be written as p multiplied by 1 by q. We can always rewrite the rational number p by q as p multiplied by 1 by q. Okay. Now this is equal to x to the power p, this whole raised to the power 1 by q, or we can also write this as x to the power 1 by q and this whole raised to the power p. But this is in general we can write, but there are some conditions we should be careful, that in general x to the power, so x to the power p by q, where p is a rational number, where q is greater than 0, p could be negative. Now the rational number p by q, whether if it is negative, then obviously I said that x cannot be 0. It has to be a non-zero real number. Okay. Now, so x to the power p by q I am writing as p multiplied by 1 by q, and this is equal to x to the power p and that whole raised to the power 1 by q. This is coming from the concept of laws of exponents where the exponent is a integer. You know that if x is a non-zero, if x is a positive real number, then x to the power m and this whole raised to the power n is equal to x to the power n this whole raised to the power m, and this all is equal to x to the power, the products, the powers get multiplied, mn. So this concept I have applied. X, the rational number p by q, I can express it as p into p multiplied by 1 by q. So now you can consider m to be p and n to be 1 by q. So this will be x to the power p whole raised to the power 1 by q, or I can write it as x to the power 1 by q and then whole raised to the power p. Okay. Now what is this? What is x to the power p and whole raised to the power 1 by q? We have seen this is nothing but the principal qth, this is the principal qth root of x to the power p. This is equal to, actually this thing, this is in the radical form, because the sorry, not radical form, this is an exponential form, but actually in the radical form this is actually principal qth root of x to the power p. Now obviously q is a natural number because principal nth root of a real number n has to be a natural number, and also if somehow x to the power p becomes negative, if x to the power p becomes negative, then q has to be a odd integer. So when you are, so the concept is when you are trying to evaluate x to the power a rational number, that is p by q, if you are rewriting it as x to the power p and then whole raised to the power 1 by q, you must ensure that x to the power p, if x to the power p is negative, if x to the power p is negative, then q has to be an odd integer. Q has to be an odd integer. And if x to the power p is positive, then q can be any natural number. Then q can be even. Then q can be any natural number. It can be odd or even. So this will be if x to the power p, whatever the value of x, or for whatever value of x and p, if x to the power is less than 0, this should imply that q is odd. This is from the definition of the principal nth root of a negative real number. Okay. Now what is this? What is so again, if you want to express x to the power p by q as x to the power 1 by q and then this whole raised to the power p, this is nothing but x to the power 1 by q is principal qth root of x, and this has been raised to the power p. In this case also, if x is less than 0, if x is less than 0, this implies q has to be odd. Then only this whole expression will be valid. So these things you have to keep in mind. If x is a positive real number, if x in this exponential form, if x is a positive real number and the rational number p by q is positive, then without any problem you can always express it as x to the power p and whole raised to the power 1 by q, or x to the power 1 by q whole raised to the power p. Okay. Now, so this was all about the exponent of a real number where the power is a rational number. Now, what are the laws? The laws are same. The laws of exponents of real numbers, where the exponent is rational exponents of real numbers, are same for integral exponents of real numbers. That is, let's so that is x. Let's say x and y are two real numbers. Then x y this whole raised to the power p by q. This will be equal to, you can break apart, this will be equal to x raised to the power p by q multiplied by y to the power p by q. P by q. And also x to the power p by q multiplied by x to the power, let's say, another rational number r by s. This is equal to x to the power p by q plus r by s. And of course x to the power p by q divided by x to the power r by s will be equal to x to the power p by q minus r by s. So this is one law, this is the another law, this is another law, and finally if you x by y, x by y this whole raised to the power p by q, you can, if you, so this is if you want to express this as a rational number, that is, this is in exponential form. If you want to express it as a rational number, this is equal to x to the power p by q divided by y to the power p by q. These laws will work well when x and y are both positive real numbers and p by q or r by s is any rational number. Okay. Now, the typical what are the typical problems that you have to solve from this concept of rational exponent of real numbers? Let's say so whenever okay, now let's say you have to simplify this exponential form. Let's say x raised to the power p by q. Now let's say x is an integer where x is an natural number. Now, as I said, this is equal to x to the power p and this whole raised to the power 1 by q, which is equal to principal qth root of x to the power p. Also, I can write it as x to the power 1 by q whole raised to the power p. This is equal to principal qth root of x and this whole raised to the power p. Now, while evaluating this exponential form term, should I should I rewrite it or express it in this form or this form, which will be easier to compute, simplify. I think it is always, if you can express the base x as in some exponential form where the power is cubed, then it will be easy to simplify. So if x, let's say if x is expressible in the form y to the power q for some y belonging to natural number, I have considered x to be a natural number and p by q some positive rational number, then if you can express x, if you can immediately mentally, if you can express x as y to the power q, a power of q, that is y to the power q where y is also a natural number, then it will be easy to simplify, because then x to the power p by q will be equal to y to the power q this whole p by q, and as I said, now you can multiply the two powers. This will be equal to y to the power q multiplied by p by q. This is equal to y to the power p. Because it will be difficult, this expression no sorry so if you try to evaluate this x to the power p by q as principal qth root of x to the power p, then first you have to find x to the power p. Now x could be a large number. Let's say if you have to evaluate, let's say 256 raised to the power 2, let's say 3 by 4. Now if you want to, so this I know I can express it as 256 to the power 3 and then this whole raised to the power 1 by 4. Now it is very tedious to compute a cube of 256. First I have to compute the cube of 256 and then I will compute the principal fourth root of whatever this value will be. This will be tedious. Instead, if I do it like this, this is also equal to 256 raised to the power 1 by 4 and then this whole raised to the power 3, which is equal to instead if I can somehow express 2 to the power 256 as a power of 4, some number raised to the power 4, let's say, so you have to be very smart and efficient in expressing a natural number as a power of some another natural number. That is, you have to be very prompt with the prime factorization. So 256, as I know, is equal to 16 multiplied by 16. So this is I can say 4 square multiplied by 4 square. So this is I can say 4 to the power 4. So now this thing I know that 256 can be expressed as 4 to the power 4, and I also know the whole expression, exponential term, the power is a rational number where the q is 4. So I will express 256 as 4 to the power 4. This becomes 4 to the power 4 whole raised to the power 3 by 4. Now this is equal to, I can multiply the product, I can multiply the powers from the laws of exponents. This becomes 4 to the power 4 multiplied by 3 by 4, this becomes 4 cube, and this is equal to 64. So this is one type of problem, how to simplify a given number, which could be in the exponential form or in the radical form. How do we simplify a given number in the radical form? Let's take an example from the book. Okay, so let's say, how do we simplify expressions like this? We have to simplify this. So this is in radical form. This is principal fifth root of some number, and that number is 32 raised to the power minus 3. Okay. Now when you have to simplify this, it is always better that you convert this into exponential form, that is exponent of a real number, where the exponent could be a rational number or some integer. Okay. So first of all, this is fifth root of inside the radicand is 32 raised to the power minus 3, which is nothing but 1 by 32 raised to the power 3, because any number, let's say any non-zero real number having a power of negative minus n, this is nothing but 1 by x raised to the power n. So now this is equal to, I know that principal nth root of x, this means x to the power 1 by n. So this will be 1 by 32 cube. The radicand was inside the radical sign, the number was 1 by 32 raised to the power cube. So this whole now raised to the power 1 by 5. So in the exponential form, this becomes, I can now multiply the two powers, and it becomes 1 by 32 raised to the power 3 by 5. So in the exponential form, the given this radical, so this number is in radical form, when expressed in the exponential form, becomes this 1 by 32 whole raised to the power 3 by 5. Now as I said, can I express in the power the rational number, the cube is 5, in the denominator we have 5, and the rational number is positive 3 by 5. The denominator is 5. So if I can somehow express the base, that is 1 by 32, as a power of 5, I can easily simplify. Now what is 32? 32 I know is 2 to the power 5. 2 to the power 5. So I can express 32 as 2 to the power 5. So I have 1 by 2 to the power 5, this whole raised to the power 3 by 5. Now 1 by 2 to the power 5 can be expressed as 1 by 2 whole raised to the power 5. And then I have this whole raised to the power 3 by 5. So now I have two powers 5 and 3 by 5. I can using the laws of exponents, that is x to the power m, this whole raised to the power n is equal to x to the power mn using this law of exponents, this becomes half raised to the power 5 multiplied by 3 by 5. This becomes half raised to the power 3. This becomes, so this is still in the exponential form. If I want to express, whenever you're asked to simplify radical or an exponential term, you have to always simplify in the rational form, and the rational form should be in the standard form. That is, the denominator should be positive, that is q should be positive. So now this is the exponential form. How will I express it in the rational form? I will have to break, that is, this is 1 cube divided by 2 cube. So now this is 1 by 8. Let's see, let's take another example. I will solve more problems in the next video. In this video, I'm just trying to I'm just trying to discuss a few example problems. More complex and difficult problems I will solve in the solving session. So I'm taking examples from the book only. Let's say, let's say, how do we simplify 625? This is raised to the power minus half, and this again is raised to the power this again is raised to the power minus 1 by 4, and this whole is raised to the power 2. This whole is raised to the power 2. Now the thing is that if all the powers, you see there are 3 powers, 3 levels of power. The innermost power is minus half, and the power in the middle layer is minus 1 by 4, and the outermost power is 2. If all these powers are non-zero, let's say you have something like this, x, where x is also a non-zero real number. You have x to the power m is the innermost power, and then this whole is raised to the power n is the middle power in the middle layer, and let's say this whole is raised to the power p, where all the powers m and p are non-zero, and also the x or the base is also non-zero real number. You can always, using a shortcut method, this will always be equal to x to the power, you just multiply all the powers m, n, p. So if I apply this shortcut, I will see this is becoming 625 whole raised to the power. I will multiply, the power now will be the product of all the powers, that is minus half multiplied by minus 4 multiplied by 2. So this is equal to 625, this whole raised to the power. If I multiply, the product of all the powers becomes 1 by 4. So now I see the power is a rational number, where the q, that is the denominator, is 4. Now I have to somehow express the base 625 as a power of 4. I know 625 is equal to 25 multiplied by 25. Now 25 is itself 5 square. So this is 5 square multiplied by 5 square, and this is equal to 5 to the power 4. So now I will express 625 as 5 to the power 4, and I have this whole raised to the power 1 by 4. Applying the laws of exponents, the powers gets multiplied. This becomes 5 raised to the power 4 multiplied by 1 by 4. This becomes 5 raised to the power 1, which is equal to 5. I hope I am correct. Let me check. Okay, 5. Now, so this was, if you see this kind of powers. Now this in this expression, there was 3 powers: minus half, minus 4, minus 1 by 4, and 2. There could be more than 3 powers. Any number of powers, if all the powers are non-zero and the base is non-zero, then you can multiply, you can express this entire expression as the base, whatever the base is, and the base raised to the power, that power will be the product of all the powers. Now, if you want to do it step by step, what you do is you first multiply, express this whole, you first multiply the first 2 powers, that is minus half and minus 1 by 4. So this will be equal to 625 raised to the power, using laws of exponents, it will be minus half multiplied by minus half, and then this whole was raised to the power 2. So this is 625 raised to the power 1 by 8, and this whole raised to the power 2. Now at this stage, if you want to simplify 625 whole raised to the power 1 by 8, you can simplify only when if you can express 625 as a power of 8. As a power of 8. Is it possible? I don't think so. So since I cannot simplify 625 raised to the power 1 by 8 to a more simpler form, because 625 cannot be expressed as any number, any integer, as a power of 8. So I have to, then I will multiply these 2 powers, 1 by 8 and 2. So this becomes 625 raised to the power 1 by 8 multiplied by 2. This becomes 625 whole raised to the power 1 by 4. So 1 by 4, we got 625 raised to the power 1 by 4, and 1 by 4, as you can see, is the product of all the powers. Since all the powers are non-zero and the base 625 is non-zero, you can while simplifying this kind of complex exponential term, you can multiply, you can find the product of all the powers, and that power will be the final power of the base. Let's take another example. Let's see how do we simplify 256 raised to the power we have the power is minus of and the minus of something, some number, and that number is again in the exponential form, which is 4 raised to the power minus 3 by 2. How do we simplify this? Now clearly we can see that this is of the form x to the power minus y, x to the power minus y, where x is 256 and y is 4 raised to the power minus 3 by 2. Now in this kind of a scenario where the power itself is in the exponential form, then first you have to simplify the powers. You have to make the power to a rational number. Now this power, we have seen that the power of the 256 is minus of something, and that something is again exponential form. So that exponential form you have to express as a rational number. So first I will try to simplify the y, which is 4 raised to the power minus 3 by 2 in the rational form. Okay, so this is 4 raised to the power minus 3 by 2. Okay, now, so this is 4 raised to the power minus 3 by 2. As I said, whenever you have this kind of, whenever you have any exponential term like this, x to the power p by q, then if you can express the base x to some power of q, always do that, then q will get cancelled out. I know in this 4 raised to the power minus 2 by 2, the power is a rational number minus 2 by 2, but the denominator is 2. So I also know the base 4 I can rewrite it as 2 square. So I have this. So now I will, using the laws of exponents, I will do the product of the powers. So this becomes 2 raised to the power 2 multiplied by minus 3 by 2. This becomes 2 raised to the power minus 3, and this is nothing but 1 by 2 to the power 3. This is 1 by 8. So y is 1 by 8, but the original number was x to the power minus y, where x is 256. So the original number is simplified to 256 raised to the power minus y, where y is found to be 1 by 8. So this is minus 1 by 8. So now again I will try to see whether I can express 256 as a power of 8, because in this whole exponential term the power is a rational number where the denominator is 8. So if I can somehow express the base as a power of 8, it will help me in the simplification. So 256 was okay, so 256. So 256, can I express it as a power of 8? 256 is, I know, 16 multiplied by 16. Okay, so 16 is 4 square multiplied by 4 square. Okay, okay, and this is 4 to the power 4, but 4, the base 4 I can always is 2 square. So this is 2 square whole raised to the power 4. This is 2 to the power 8. So 256 is 2 to the power 8. These small powers that is expressing some number as a power of some another number, you have to be very all these things should be at your fingertips, and this will come with practice, lot of practice. So now 256 is 2 to the power 8, and this whole raised to the power minus 1 by 8. So this is 2 to the power 8 multiplied by minus 1 by 8. This becomes 2 to the power minus 1, and this is 1 by 2. I think I should end the video here. So I just solved a few examples to illustrate how we simplify these terms. So I will in the next video I will solve some problems in doing simplification of some radical number, of some number given in the radical form or in the exponential form to a rational number in the standard form. And then I will in the subsequent topic, and then after the next video I will discuss about how do we solve unknown variables in an exponential equation, like exponential equation, let's say, where we have an equation where both the sides LHS and RHS are some exponential terms, and there is some unknown variable either in the base or in the power. Let's say, for example, 2 to the power x is equal to, let's say, 2 to the if we are given now both the sides, both LHS and RHS may not be in the exponential form, like 2 to the power x is equal to 8. From this equation, how do we solve x? I can write 8 as in the exponential form. So how do we solve this kind of equation? Or even, let's say, if we have 2 to the power x minus 1 by 2 is equal to, let's say, 2 to the power, or let's say 4 to the power x by 3. So in this equation we can see both the LHS and RHS are in the exponential form and the unknown variable is in the power. How do we solve for x? We have to find x. The unknown will be sometimes in the power on the both the sides, or it will be in the base. For example, it could also be in the base. Let's say x minus 1 by 2 cube is equal to, let's say 81. How do we now solve for x? Now clearly the unknown variable is only in the base on the left hand side. If I convert the RHS in the exponential form, this will be 3 to the power 3. So the idea is that, so we will discuss about how to solve this kind of exponential equation where the unknown variable is either in the base or in the power in the subsequent video, that is after the next video. In the next video I will solve how to simplify some exponential some terms given in the radical form or exponential form to a rational number. I will end the video here. I hope this video was beneficial. If it is so, then please like it, share it with your friends, and please support me by subscribing to my channel, and in that case do not forget to press the bell icon so that you will be notified by my future videos. Thanks for watching, and until the next video, take care and bye.